Okay, so here, back in AB, we solved differential equations that looked like this. Same thing, y prime is dy dt. And we got this exponential. And we said, hey, this is no longer always realistic to always be an exponential growth, right? Because eventually it could become logistic growth. The logistic growth differential equation is this guy right here. So this is the logistic growth differential equation. Now we're going to learn how to solve this, but let's first get all of those components. In order to be a logistic growth, I have to have same variable going on. If those are not the same, it is not logistic growth. So all of these have to be the same. Or I could have said y prime, right, instead of y dx. Then, going on in front of this y right here has to be a 1. So there cannot be a coefficient in front of that y. When you have this set up, A is my carrying capacity. And K is my, any idea? It is a coefficient, but it's the growth rate. Okay? Exactly. Okay. Okay, and this is basically what we just talked about with Kellen's fishies. When we go to solve this differential equation, this is what it solves to. We are going to solve that, you're going to see, and you are going to have the opportunity to either memorize this or do the process that I'm going to show you. That's fun. So looking at this, what are the horizontal asymptotes for this function when we solve it? So in order to find a horizontal asymptote, what two things do I have to do? I have to do two things. It's the AB. Horizontal asymptote. Okay, so you're thinking the like the horizontal tangents. Yeah, you're thinking in parametric. I want to go back to just plain old rectangular. What two things do we have to do to get the horizontal asymptotes here? So that's the process of what we're going to do once we know what's the setup, and then that's kind of what we're doing is the coefficient stuff. We have to take limits. A limit as t approaches infinity, and the limit as t approaches negative. Good job. Okay. I know, right? Okay. So these are the two things we're going to have to do for horizontal asymptotes. So let's look. If I take the limit as t goes to infinity of this guy right here, it's basically going to be a over 1 plus e going to what? Negative infinity. And as e goes to negative infinity, what am I getting out? Here's my graph, right, of e. So it is 0, but what does that become as e goes to negative infinity? 0. Yes? is just A over 1. Or A. Now think about that. We'll come back here. We just said the horizontal asymptote is y equals A for one of them. Do we agree? Here's a horizontal asymptote at y equals A. Is A the carrying capacity? Yeah. So does that make sense? Sure it does. Okay, so then the other thing for the horizontal asymptote that I have to do is take the limit as t goes to negative infinity. What do I get out here? It's basically a over 1 plus e going to now infinity, which gives me what on the bottom? Infinity, and a over infinity goes to 0. So I know my other one is y equals 0. That one's not as important. Okay? Really wanted to see the carrying capacity. Okay, so there is a visual example of the slope field for logistic growth. If you were to take that differential equation and make all those little tiny slopes, right, it would end up looking like the logistic growth. And what do you notice at 0? What do we have going on? Horizontal asymptote. What happens with the carrying capacity? You have a horizontal asymptote. Okay? Okay. Look how much space you can. Too much blank space. And you're going to use it all, and you still don't want to write too big. Okay. So we are going to solve this differential equation.
But if we can memorize it, why do we think we need to go?
You're going to eat your vegetables. Okay. So, first thing when we solve, I'm going to go ahead and cross multiply. Get the y's with the dy's, get the t's with the dt's. Anything I can leave over on that t side, I'm going to. Because eventually we're going to have to get it there anyway. Okay? So let's see, that would end up being dy plus ky a minus y dt. So what's the only thing I can leave with the dt? K. Okay? That a minus y is going to have to go and get divided over. So I have 1 over y times a minus y dy equals k dt. Yes? Now, what do we have to do to both sides?
Integrate.
Integrate. Isn't it great? Okay. So we have this. How are we going to integrate the left-hand side? Duh, but you got to do something else first. No. No, it's factored down there in the denominator.
Ew.
Oh, okay, so we're going to have to do partial fraction. Which is a good, review for us anyway, right? So as I go to do my partial fractions, I know I want something over y plus something over a minus y to equal 1 over y times a minus y. Now, we used to write a and b, for if it's linear, to be a constant on top, but do I want to use a? No, so what should I use? B and C. You can use Q if you want, but I'm going to use B and C. Okay, what do I need to multiply top and bottom by for the first one? Okay, so I'm going to have that B times a minus y. And I'm basically getting rid of the denominators and setting the numerators equal again. Yes? Plus C times y equals 1. Now we pick our magic numbers. y to equal 0, and we need y to equal a. No, those are the magic numbers that we're plugging in. Okay, so in both cases, I got b and c to equal 1 over a. So this basically means I'm going to have the integral of 1 over a over y plus 1 over a minus y dy equals the integral of k dt. What can I do with that 1 over a to make my life a little bit easier? Take it out in front of the integral, because it's just a number. Good? Now, Chris. Okay, now, Chris, what can I do? The ln rules. And be careful on one of your ln rules that you don't make this mistake. You know what I'm talking about? Okay. It's one of the things I said I got to talk about. So this one is just the ln absolute value of y. What's the next one? Is it plus? No, it's actually minus. Do you remember that tricky part that we've talked about before?
Why?
Because when you have the ln rule, you are integrating u prime over u. Okay? So you need a negative 1 here. The derivative of this guy is a negative 1. So in order for that guy to work, to put that negative, I'm also going to have the other negative, and that's where it came from. Okay. Equals kt plus c. All right, now what? You're solving for y. That's a good question. So what do we have to do next? We can multiply by a, and in the same step, what could I do? Simplify the ln's. So let's multiply by a and simplify the ln's all together in one step. Good? Okay, now what? Just e it. So we have all the y's on one side, but not in a way that is beneficial to me. Because I can't have them in the denominator. So I need to do what? And then move the y's back to the same side. Yeah, multiply by that a minus y. And now I can move my y's over to factor out the y. Yes? you factor and divide in the same step? Or do you want to factor and then divide? Factor then divide? Okay. So there's my factoring, and I'm going to divide. And we've solved for y, and life is good. Except for it doesn't match the equation on the previous part of the thing. So what do they have in the equation on the numerator for y? They just have the a. So in order to just have the a, what can I multiply or divide by, basically? 1 multiplied by 1 over. What can I do to both sides? Divide by, yeah, that whole thing, right? So that would just give me, oh, it's already froze. So really. Alright, so where were we? Y equals ACE to the AKT over 1 plus CE to the AKT. Okay, we said we're going to divide. Alright, so this is where we were. So this just becomes A over 1 divided by CE to the AKT plus what? Now we're really, 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 really close. That's basically 1 over C times 1 over e to the AKT. Yes? So 1 over C is just C, and then 1 over e to the AKT is e to the negative AKT plus 1. And the only other difference is the plus, right? But if we want to do our commutative law. And that's where it came from. Ta-da! You did it! Good job! Grant says, I think I'll just memorize. Yeah. I don't know. I kind of find it fun to do, though. I worked it out in your test. I worked it out. Because it was fun. No, if you memorize it, you're fine. But I think it's fun. Alright, we're going to skip this one. It's easy. Okay, let's look at this one.
Skipping the
What is this one?
Yeah, we're going to this one. Yeah, the first one's too easy. Okay, so let's look at this. I know. Yeah, we're fine. Okay. Is the first one logistic growth?
Yeah.
Do I have same, same, same? Do I have a 1 in front of that guy?
Yeah.
Yes, and it's a minus 1. Okay, so that is logistic growth. What is my carrying capacity here? 1. So it says when are the equations growing the fastest? At 10. What equals 10 here? T or Y? It is a Y. It's always on the Y-axis. So when we are doing this logistic growth, where it's growing the fastest is A over 2, it is not a T value. It is a Y value. one logistic growth. Yeah, these have y prime, but same, and it has that -1. So my carrying capacity was 5, so where am I growing the fastest? When y equals 2.5 or 5 halves. Good? Alright, those are really easy. So now let's look at this one. Okay, the number of that's what everybody would do. In a national park is modeled by the function m that satisfies this differential equation, where t is the time in years and m of 0 is 50. What is the limit as t goes to infinity of m of t? Is this logistic growth? We don't know yet, do we? It's not quite set up how we want it, so we need to see if we can manipulate it how we want it. What's bad here? Yeah, that 1/200. Wah, wah, wah. Okay, so that's the bad thing. So I'm going to go ahead, and some of you guys will do this really fast, and that's fine. But I'm going to get this guy into a common denominator of what's wrong here. So this would end up being 200/200. Yes? Now I can factor out from the parentheses the 1/200. Good still? Now is it logistic growth?
Yes.
Yes. So now it's saying, what's the limit as t goes to infinity?
200.
Yeah, it's the carrying capacity, which is 200. Yes? Okay.
200 doses.
Okay, see if you can do this one with your buddies. Go. So you could have wrote what? C prime or dc dt equals 9c minus 3c squared. Doesn't quite look logistic, but I can factor out a 3c. So now it says, for what value of c is the number of coyotes increasing the fastest?
1.5.
Okay, so when c is at carrying capacity divided by 2, which would be how many coyotes, by the way?
1.5 thousand.
Yeah, so 1,500 coyotes. Just FYI. Still good? Okay, I'm going to give you 15 seconds for this next one. Go. 1, 2, 3, 4, 5, 6, 7, 8, 13. Answer. Green. E. Okay.
Did anyone say B? You get your
I didn't hear B. I only heard E. Okay, so this is a free response question from the AP exam. It says let f be a function with f of 4 equals 1 such that all points x, y on the graph of f satisfy this differential equation. Is this logistic growth? No. Kind of looks like it, but is it? No. And sometimes they're going to try to trick you on that. I saw an AP test once. They had this graph that looked logistic, and then they ended up writing something that looked like, I don't know, I think maybe something like this. And it was like, is that logistic? No, it was really, really similar though. And I was like, oh, man, that was me, because they even put the graph down below that looked logistic. And anyway, it was me.
tricky.
I know. Okay, so pay attention, okay?
Like, I would have definitely thought it was.
So there's my F stuff. Alright, so there's F. Then they give me some G stuff. And they told me G of 4 is 1. And they give me this differential equation. Is it logistic?
Yeah.
Yes, they even told you. Thank you. Okay, so on part A, it's a review question. It says find y equals f of x. And this was either 5 or 6 points out of the 9. I can't remember exactly. But out of 108 points total, is that a lot? Yeah. That's a lot. Especially when you need like just 60 to get a 5. Okay? I don't know, maybe like 68. Whatever. Something around there. Okay, so find y equals f of x. What are they asking you to do? Solve the differential equation. So that's just an old one. Go. If you had your 2 over here, I wouldn't suggest that because you don't need it. Again, keep everything over there. But if you had this, then you need to think of it like that. Okay? Again, I would not suggest that because eventually you're going to have to bring it back anyway. So, yeah. So why? far? Okay. Are you plugging in your value, solving for C? They gave you, do you not have your notes? We're on F. So F of 4 is 1. I don't care which way you want to do it. And I know that they put all that together. But you don't have to. You could have left it e to the negative 8 out in front or 1 over e to the 8 out in front. Doesn't matter. Everybody good? Okay. So part B. Given that g of 4 is 1, find the limit as x approaches infinity of g of x and the limit as x approaches infinity of g prime of x. Again, when I hear these limits, and I know it's logistic, I think it's easiest to kind of just sketch it, and then everything's going to be a lot easier. Okay? So let's sketch this logistic growth differential equation, or the logistic growth equation from that differential, what we know. Okay, so it's growing something, the carrying capacity. And it was on t and what other value? Or no, it was x and y. Okay. And this was rg. Agreed? It can. Depends on, like, for Kel and I said he started with 150. Okay. Okay, so the limit as x goes to infinity of g of x is just 3. That's not so bad. Agreed? So the next one that's it's fun to think about. Now I'm asking about g prime. And we're really tempted to go back up and look at that differential equation. But just look at the graph. G prime on the graph of g represents the what? Slopes. So if I look at my slopes going on, what happens as I go to infinity? The slope goes to 0. 3 is the carrying capacity. It's going to be, yes. And then C, for what value of f does for what value of y does the graph of g have a point of inflection? 1.5 or 3/2. Questions over that one? So now we just have like 3 multiple choice that are fairly quick. You get 20 seconds for this next one. Go. Answer. t is the size of a population at time t. Which of the following differential equations describes the linear growth and the size of the population? So if I have linear growth, then the derivative is what? Yes? So that answer would be A. But I want to change this up a little bit. We've seen this one. I want to say describes quadratic growth. And now we've got two that we really have to pick from, yes? Which two would be like, I see two that kind of look linear. Yeah, B and D. Because I know the derivative would be linear. Which one of those, when you solve though, is going to give you a quadratic? D? B? Okay, let's go C. So dP equals 200C dt. So P equals 100t squared plus c. Quadratic? Okay, let's go to this one. 1 over p dp equals 200 dt. What's that going to end up? ln absolute value of p equals 200 t plus c. And then I have to
No.
c e to the 200t.
Also,
Yeah.
what would we do?
Wouldn't it be the other way because it's asking for
Well, you could, yes, but I mean, you need to like see it all as a whole. Okay.
There
So
would be no P for the second part of the ones there because you've got just that goes away.
no, the antiderivative of a constant is linear. So it's 200t. Okay, last one. I have